Okay, so we're going to look at surd equations now. So a surd equation, obviously, it's kind of in the name. It's an equation that has some surds in it. And our main kind of, I suppose, approach or tool, if you like, in these equations would be squaring, obviously. So the opposite or the inverse operation of a square root would be squaring. So that's kind of the best way we can eliminate a surd. What we need to be careful of is kind of when we make use of that. So that's going to be the key thing going through this, is when do we choose to square and square both sides. The other thing that's important with these is that we have to always check our solutions. Now, we haven't always seen that in many of the equations we've done. So generally in our equations, we solve them, we get our answers for x, we're happy out. In these surd equations, some of the answers we get will not be possible. Because we're squaring, we are kind of including answers like particularly negative answers or things that can result in a negative answer under the square root that, yes, do work if I've squared the equation, but wouldn't work in the original equation that had the surds. So we have to always check our solutions, and that's the sort of thing that you can lose the mark or two for at the end of the question if you haven't checked your answer. So you have to always verify these solutions. Now, I suppose to say, it's always good practice to verify all your answers, but particularly with these ones, it's part of the method that we have. So we have two different types we're going to be looking at. The first is surd equations that have one surd. So they only have one square root in the whole question. And how do we focus on those? The first step we're going to have is isolate the surd on one side, so on its own. We're going to put everything else to the other side of my equation, and then I'm going to square both sides. So you can see we have a bit of setup to do before we make use of our squaring, before we make use of that tool that we have. So I'm going to isolate the surd, I'm going to bring all the terms to the other side, then I'm going to square both sides, and then I need to check that my answers are valid. So checking that my answers are valid just means making sure they're both allowed. So I sub into the original equation. So looking at how that kind of works then. So as I've said, we isolate the surd. So in this equation here, I want to get the 2x on its own, and I'm going to put anything else on the other side. So 4 minus x on the other side there. This is the point now where I'm going to make use of my squaring. So I need to square both sides. Now we have to be careful with this as well in squaring, particularly the right hand side here, but you'll see what I mean in a second. So square root of 2x just obviously squares to 2x, just removes the square root. When I'm squaring the right hand side, I need to make sure I include all the parts in that square root. Okay, so squaring a bracket like that should give me 4 terms, which I can generally reduce to 3. Okay, but it's a perfect square. So we need to be careful with that, because that's the part that people forget as well, is that middle term in the bracket. So I can't just write down 4 squared and minus x squared. I need that middle part as well. So the last thing I need to do now is get everything over to one side. Here we can kind of see what it's shaping up to be. It kind of looks like it's going to be a quadratic of some sort, and I'm just going to flip it around so it looks more like what we're used to. So I now need 2 numbers to multiply to give me 10, but add to give me 16. So two numbers to multiply to give me 16, but add to give me 10, excuse me. So we'll say minus 8 and minus 2. And I get my 2 answers being 8 and 2. Now I need to verify or check my answers. I need to verify or I need to check my answers. So we're going to sub them into the original equation. So x plus root 2x equals 4. So let's start with 8. So 8 plus root 2 times 8 equals 4. Well, does it? 8 plus root 16 equals 4. 8 plus 4 equals 4. And 12, of course, does not equal 4. Doing my second answer here, so let me see, I'm going to do that one over here. So that is for 2. So 2 plus the square root of 2 times 2. And we want that to be equal to 4. So 2 plus root 4 equals 4. The square root of 4 is just 2. So we get 4 is equal to 4. And that, of course, is correct. So 4 is equal to 4. So that's perfect. Okay, one thing to talk about here as well, which can come up a lot with our surd equations, is just that idea of the square root, and particularly say square root of 4. So in this idea, the square root of 4 is always 2. Square root of 4, it's always 2. Where the difference can come in is if I have x squared is equal to 4, then that means that x could be either plus or minus 2. So because what I'm saying in the second one there is I have some number, and when I square it, I get 4. So x could be plus or minus 2. But the square root of 4 in and of itself is always just 2. Okay, just a point to note for yourself there. Because that can kind of impact you verifying your solutions here. So square root is always 2, but if x squared is equal to 4, x could be plus or minus 2. And it comes back to your kind of difference of two squares idea. Let's just look at another one or two of these examples, I suppose. So if we look at this next example here, we only have 1/3. It's already on one side on its own. So nice and straightforward. We're just going to go straight with squaring both sides. X squared equals 2x plus 8. Bring everything to one side. So 2x plus 8, or minus 8, sorry. Bringing everything over to the other side. So again, two numbers that multiply to give me minus 8, but add to give me minus 2. So that's just going to be minus 4 and plus 2. So I get that x is equal to 4 and x is equal to minus 2. Now again, as before, we're going to verify. I'm going to check my answers. So I'm subbing into my original equation there. So I want to know, is 4 equal to the square root of 2 times 4 plus 8? Is 4 8 plus 8? Is 4 root 16? Yes, it is. Okay, let's do the same with my other example. Is minus 2, and I'm kind of immediately thinking that this probably isn't going to work, equal to minus 2 plus 8? Is minus 2 equal to minus 4 plus 8? Is minus 2 equal to the square root of 4? And based on what we've just said, no, it's not. Square root of 4, of course, is 2. The square root of 4 is 2, so we can see straight away that no, minus 2 is not equal to 2. So that's not an answer. So we finish off our question by saying that x must be equal to 4. And something we forgot in the last one as well was just to say x there was equal to 2. So just finishing that off by giving your answer. Okay, let's look at the last little example here. Same thing again, we're going to put the third on one side, we're going to put everything else on the other side. What I'm going to do this time is I'm going to bring everything over to the left and put my square root on the right, just so I can kind of avoid that negative sign there. Save me a little bit of trouble. 5x minus 1 squared. So I get x squared minus 10x plus 25 equals 5x minus 1. So x squared minus 15x plus 26 equals 0. So two numbers that multiply to give me 26 but will add to give me 15. So it's going to be x minus 13 and x minus 2. So my two answers are 13 and 2. I'm going to verify those subbing into my original equation. So is 13 minus 5 times 13 minus 1 equal to 5? Well, I don't know. Let's see. 5 times 13, what is that going to give me? 5 times 13 is 65. Okay. 5 times 13. Oh, sorry, I've made a mistake in my writing it out there. I should have the square root over all of it. So 65 minus 1 equals 5. Square root of 64, 5. The square root of 64, of course, is 8. Jumping ahead there. Jumping ahead a little bit, but 13 minus 8, of course, is 5. So I get my answer. Checking now with 2 is 2 minus the square root of 5 times 2 minus 1. Is that equal to 5? So 2 minus 10 minus 1, which of course is going to be 9. So is 2 minus 3 equal to 5? Minus 1, of course, not equal to 5. So therefore my answer is that x is equal to 13. So we can see there, so long as you're following the same steps and following your answers through there, you shouldn't have any real issues with getting the solutions out. The key thing there being verify your answers. Okay, we've a lot of working going on there, but verifying your answers is really the last key step, because as you can see in each of those questions, only one of the answers was actually a possible solution. Now when we have two surds, the only thing that changes is you're going to put one surd on each side. So we've already said that we want to isolate the surds. Like if we have one surd equation in the whole question, we want to isolate that surd. If we have two, we want to isolate each of them. So we put one surd to each side, and then we square both sides. If there are any surds remaining, which there probably will be, we're going to isolate and we're going to square those surds as above. So if there's any surds remaining, there should only probably be one, and we will just isolate it and square it like the questions we had there, and then we're going to solve the equation that's left. And again, we need to just check our answers by subbing them back into the original equation. So let's just look at these two. The first one there, again, I have two surds. The first step I need to do is get the surds on their own. So what I would probably do here is leave the biggest surd on its own. If there are any numbers, maybe put those numbers with a smaller surd so that you have a little bit less to deal with. So the 5x plus 6, immediately now the square root's just eliminated. I get 2x plus 4 root 2x in total here, plus 4. Okay, now as I've said already, I'm going to isolate whatever's left. So if I bring that over, I get 3x. So I get 3x plus 2 equals 4 root 2x. Okay, 3x plus 2 equals 4 root 2x. Now we've ended up with something similar to what we had in the first part here, in those first types of questions. So we just do the same thing again. We're going to square both sides. And we have an interesting part here where we have a 4 in front of my surd. So we just need to be careful with that. So 9x squared plus 6x plus 6x, so plus 12x plus 4. And this gives me 16 times 2x. So I'm squaring the 4 and I'm squaring the 2x. So 9x squared plus 12x plus 4 equals 32x. Bringing everything now to one side, I get minus 20x plus 4 equal to 0. So 9x squared minus 20x plus 4 equals to 0. Putting that into brackets, I get 9x minus 2 and x minus 2. Okay, so do that one out for yourself if you're unsure. But we're just kind of, since we're focusing, I suppose, on our square roots here, let's just jump straight to some answers. Once I've got my answers here, I need to verify. So let's just pick one first of all. So it was 5 times 2 over 9. 5 times 2 over 9 plus 6 minus root 2 times 2 over 9. And we want to know, is that going to be equal to 2? Okay, so let's work it out. So 5 times 2 over 9, of course, is 10 over 9. Let's just double check. 10 over 9 plus 6 is 64 over 9. So square root of 64 over 9 minus, and that's going to be 4 over 9. Square root of 4 over 9. And is that going to be equal to 2? Well, let's see. Square root of 64 over 9 is 8 over 3 minus 2 over 3. 2 gives you 6 over 3, which is, of course, equal to 2. So 2 over 9 is a possible solution that we have here. For trying the other solution then, 5 times 2 plus 6 minus 2 times 2. And is that equal to 2? So 10 plus 6 minus 4. So root 16 minus root 4, is that equal to 2? Well, we have 4 minus 2, and I get 2 is equal to 2. So my two answers are both valid solutions, and we haven't had that yet, but just to show that it is in fact possible that both of your answers could work out to be solutions of your equation. So that's absolutely perfect. Looking at the next one now, we can already see a little bit longer. It looks a little bit more like there's going to be a little bit more work involved, but I'm going to focus on it the same way. Okay, it doesn't really matter which part I put the surd to there. So moving it over, and then I'm going to square both sides. Squaring this one means the surd is eliminated immediately. 4 plus 4 root x minus 2 plus x minus 2. Let's bring everything over to one side, anything that's not a surd. So bringing the x over, I get 2x here, and my numbers then give me minus 4 overall. Minus 4 overall. 4 x minus 2. So again, I'm going to square both sides here. So I get 4x squared minus 16x plus 16, and here I get 16 times x minus 2. 4x squared minus 16x plus 16 equals 16x minus 32. Okay, so 4x squared minus 32x, and I have minus 32, and I'm bringing that across, so I get plus 48. Okay, let's see, can I divide across it by anything here? And I can divide across by 4. So 4 minus 8x plus 12. So two numbers that are going to multiply to give me 12, but add to give me 8. Of course, minus 6 minus 2. So x equals 6 and x equals 2. Now, as before, we need to verify my two answers here. So let me look back. So root 3 times x, so let's start with 6, minus 2, minus root 6 minus 2. And we want to know, is that equal to 2? So let's work it out. I get 18 minus 2 minus root 4. So 18 minus 2, of course, 16. So that's 4 minus 2, and we get 2 is equal to 2. And trying out my other option here, of course, is 2. So working it out just in the same way. And is that equal to 2? Well, 6 minus 2 minus 0. So root 4 minus 0. And is root 4 equal to 2? Of course it is. So again, we have our two answers, both valid here in this case. And just making it clear there what our two answers are. So same idea applies. We can see the only slight difference is just isolating each of those surds, putting them onto separate sides, and then squaring as before, and then the fact that you may have to do it for a second time when you go through. So let's have a look now at an exam question or two. We mightn't do all of these, but we can talk through all of them. But let's look at the first one here. So root 2x plus 3 is equal to 2x minus 3. And we need to verify or solve for x in this case. So let's start off, we square both sides. So 2x plus 3 squared equals 2x minus 3 squared. So I get 2x plus 3 equals 4x squared minus 12x plus 9. Again, I'm just bringing everything onto one side here. 4x squared minus 14x plus 6. Let's just rewrite that. Over here, I'm going to divide across by 2. Just try and make it a little bit simpler for myself. So I'm going to need two numbers that will multiply to give me 6, but will add to give me 7. So, of course, that's going to be minus 6x and minus 1x. We can factor out. So I have 2x minus 1, x minus 3. So I get that x is equal to a half, or x is equal to 3. Now that I've got my two solutions, I need to verify. So root 2 times a half plus 3 is equal to 2 times a half minus 3. So 1 plus 3, is that equal to 1 minus 3? Is root 4 equal to minus 2? And of course, from our little discussion earlier on, we know that it's not. Looking at the second option here is 2 times 3 plus 3 equal to 2 times 3 minus 3. Well, is root 6 plus 3 equal to 6 minus 3? Is root 9 equal to 3? And we know, of course, 3 is equal to 3. So our answer for that first question is that x is equal to 3 and only 3. Okay. I'm actually not going to go out through this second exam question here from 2019. If we have a quick look at it, I've put it into the surd equation part, but in fact, it wouldn't fully qualify as a surd equation here because we actually have no surd, we actually have no equation part in the surd. Why were there balloons? Weird. We actually have no x's within a surd part. So for that one, let's just say the balloons are celebrating. We're not doing this question, okay? We're going to continue on. I'm going to look at the next question. So root 5x plus 1 plus root x plus 1 is equal to 6. And we just want to test, is that true? Is that actually true? So let's have a look. Same thing as before, 5x plus 1 equals 6 minus root x plus 1, 5x plus 1, and squaring this side as well. So it gives me 5x plus 1 and 36 minus 12 root x plus 1 minus x plus 1. Okay, the thing to be careful of here is going to be that minus part in front of the x plus 1. Okay, that's definitely something to watch out for a little bit, okay, and make sure that we're happy with. But in fact, it should be plus, okay. So things like that are the things to be important. So because it's minus root x plus 1 multiplied by minus root x plus 1, that's going to, of course, give me a plus x plus 1. Okay, the minus 12 root x plus 1, of course, watch out for that as well. If we had a minus in that one, I'm just saying to be careful with our brackets. I'm doing these too long at this stage. So let's see. 5x plus 1, we're going to bring anything over to one side. So anything that has a square root will bring to one side, anything that doesn't will bring to the other side. Okay, and we're going to sort it out that way. So I'm going to just bring everything over and organize it first. So bring all my x's over to this side. Minus 36 equals minus 12 root x plus 1. Okay, so just so I can kind of organize, see what's happening. Now we can square it from there. So we can square both sides from here. I'm just going to take it from this step here. 16x squared minus, let's see, 36 times 4 gives me 144. If I times that by 2, 288x, and then 36 times 36 gives me 1296. Okay, squaring this part here, the minus 12 and minus 12 is going to give me 144 times x plus 1. So 16x squared minus 288x plus 1296, so it's getting quite large, 144x plus 144. So we're getting into kind of big numbers already. So let's simplify down if we can. 16x squared, let me see, 288 plus 144 gives me 432, so minus 432x, and the 1296 minus the 144 gives me 1152. Now, if we look at this here, we can actually divide across by 16 by kind of process of elimination. We can always see if our leading coefficient divides in, because if the whole leading coefficient divides in, that just leaves things a little bit easier for us. Plus 72. So two numbers that will multiply to give me 72, but would add to give me 27. And it's actually going to be minus 24 and minus 3. So I get x equals 24 and I get x equals 3. So lastly, we just need to verify my solutions. So I'll just do that over here. So verify my solutions. I'm just going to be subbing in. So 5 times 24 plus 1 plus 24 plus 1. And is that equal to 6? So 5 times 24, 120 plus 1 plus 25. Is that equal to 6? Well, it's the square root of 121 plus the square root of 5. So 11 plus 5, and of course that is not going to be equal to 6. Okay, 11 plus 5, of course 16, which is not going to be equal to 6. Testing my second solution here. Same as before, 5 times 3 plus 1 plus 3 plus 1, and is that equal to 6? 15 plus 1 plus 4. So 16 plus 4 equals 6. 4 plus 2, and 6 does of course equal to 6. So my answer there is just 3. X is equal to 3. Okay, so with our surd equations, the key thing for you to watch out for is the type of surd equation that you have. We've done loads of examples and questions for you there. So if it's with two surds, we need to get one surd on each side and square both sides then. If it's one surd, then we can just immediately isolate that surd on its own on one side and then square everything again. So as we said at the start, squaring is kind of your best tool that you have in these questions, but you just need to make sure you've set up the question appropriately in order to, before you square.